Hello everyone. We are learning to find out the area of triangle since a very long time. Now the question arises here that how do we find the area of triangle whose coordinates are given to us? Now we know very basic formula of finding out the area of triangle. It's half base into altitude. Now since we know the coordinates of all the vertices, we can calculate the side lengths of all the sides. But can we also find the length of this height? We can't. So we can't apply this method to find the area of this triangle. In a previous class, we had also learned about Heron's formula, which says that the area of triangle was under root of s minus a, s minus b and s minus c, where a, b, c were the side lengths of the triangle and s was the semi-perimeter or half the perimeter. So the value of s was a plus b plus c by 2. So can we apply the Heron's formula to find the area of this triangle? Yeah, we can. We can find out the lengths of all the sides a, b, c by using the distance formula, and then we can find the semi-perimeter and finally the area of triangle. But isn't it going to be a very lengthy process? Since we have to find first the distances of all the sides, then we have to find the semi-perimeter, and finally we have to calculate the area. So it is going to be a very lengthy process. So it would be very easy if we had a process which involved just the coordinates of this triangle. So let us understand that process and how do we calculate the area of a triangle by using only the coordinates of the triangle. Now let's take out the coordinate axis and let's draw the triangle on this coordinate axis. So here you can see the triangle ABC and its coordinates are x1, y1, x2, y2 and x3, y3. Now we have to find out the area of this triangle in the form which only involves the coordinates of point A, point B and point C. Now for that, let's have some construction. Let's draw BD, AE and let's also draw CF. So now you can see that we are getting some trapezium over here, and we can write down the area of this triangle in terms of these trapeziums. The area of triangle will be the sum of trapezium BDEA and AEFC, and we have to subtract this trapezium BDFC from it. So we can write down the area of triangle as area of trapezium 1 plus area of trapezium 2 and minus area of trapezium 3. And we know what is the area of trapezium. It is half sum of parallel sides into height. Now let's put the respective values in the relation to find the area of triangle. So we can write down this as half, put the values, sum of parallel sides is BD plus AE and its height is DE plus this is half sum of parallel sides is AE plus CF into we have to multiply this height is EF and minus half this will be equals to BD plus CF and its height is DF. So just put the values. We know the coordinates of ABC, so we can know the lengths of this BD, AE, CF and also DE, EF and DF. So this length BD will be equals to Y2, this length AE will be equals to Y1 and this length CF will be equals to Y3. Similarly, we know this length OD is equals to X2, OE is equals to X1 and OF is equals to X3. So we can find out this length DE will be X1 minus X2. Similarly, EF will be equals to X3 minus X1 and DF will be equals to X3 minus X2. So let's put the values. So this will be half, this will be y2 plus y1 into the height. This is DE. So the length of DE will be equals to x1 minus x2 and plus half. This will be equals to y1 plus y3 into the length of EF is equals to x3 minus x1. So put the value x3 minus x1 and we have to subtract the area of third trapezium. So this will be half. This length is y2 plus y3 and in bracket it will come out to be x3 minus x2. x3 minus x2. Now when we solve this out, we get the final value of area of triangle in the form half bracket. This comes out to be x1 y2 minus y3. It comes in the serial order, which is 1, 2, 3. Let's see how. Plus x2, and if you follow the serial order, here will come y3 minus y1. And finally, following the serial order, x3 in bracket, it will come y1 minus y2. And this whole term is multiplied by 1 by 2. So this is one way of getting this area of triangle. There is one more method to get the value of area of this triangle. If we solve this further, we get the relation half. In bracket, we will be getting x1 y2 minus x2 y1 plus it is x2 y3 minus x3 y2 and plus finally it comes x3 y1 minus x1 y3. So the method to remember this expression is we write first the coordinates in the form x1 y1, x2 y2, x3 y3 and x1 y1. Then we make arrows from x1 to y2, x2 to y3, then x3 to y1, and similarly we make arrows this way. So the arrows which are pointing from left to right come out to be positive and the arrows which are going from right to left come out to be negative. So our final expression comes out to be x1 y2 minus x2 y1 and so on, and finally we multiply this whole expression by 1 by 2. So this is the method to remember the second expression. So we can apply both the expression and find out the area of any triangle whose coordinates are given to us.